Thank you. All right, so today what we're going to do is we're going to look at a topic that we've looked at before, but of course we're expanding our system, right? Before we were working only with numbers and operations, which is arithmetic. Now we've added those variables in, and so we're now working not with arithmetic, but algebra. There you go. And that's really the only difference. There are no extra operations, and there are different rules because of the different system, but you'll be happy to know that the rules for working with fractions do not change. And since we have already done fractions, I expect you all to be able to do these in your sleep, right? We're going to be able to do these really quickly.
Not at all.
All right. So what we're going to do is I'm just going to remind you of the guys. Come on. I'm going to remind you of the rules. We're going to do a few of them together on Education Perfect. Then you're going to be doing some on your own, and I will run across the room and ask questions, right? So remember, who gets asked a question? Everybody, right?
Including you.
So be prepared.
Yeah, including you. Can you put your own name in the random, please?
Sure.
Please do it.
All right.
It will be so fun.
Okay.
And who's going
All right, so here we go. So the first thing we want to talk about is what a fraction is and what it means. Remember, it's just sum A over B, which literally means that you're dividing the top thing by the bottom thing, right? Top one's called the numerator. Bottom one's called the denominator. Good. And remember that the first rule and most important thing is that fractions must always be simplified, also known as reduced.
No, it's the same.
Remember that? Okay. Now, that simply means divide away, not that other word. Divide away any factors that are common. What is that noise? Common to both numerator and denominator. Okay?
Is that a dictionary definition? You know, when you search something out.
That's right.
This is self-memorized.
Very.
Wait, hold on, I'm not finished.
Okay. So divide away any factors that are common to both numerator and denominator. So factor means anything that divides evenly, right?
Yes.
But now what's going to be slightly different here is that not only do you have numbers, you're also going to have variables, right? Okay. So, but remember, you're just dividing. So say, for example, we have 12 over 24. That's just an arithmetic fraction because there are no variables, right? Well, what number will divide evenly into 12 and 24 at the same time?
Wow.
Yeah. But remember, if you did see that you divided by 2, you could divide by 2. But am I done? No, they'll divide again by what? 3, 2, 6, whatever. It doesn't matter. Remember that it's not a race. You don't worry about how fast you get there. Make sure you get there. So if it's easier for you to divide by 2 or 3 than and if you don't see it's 12, that's perfectly fine. But always look at the answer that you get and see if it will continue to factor some more, right? So the only difference that we're going to have is that instead of 12 and 24, we're going to have variables as well, right? But don't worry about it. You just follow the same rules for division. 2 and 6 will both divide by what? 2. So that's going to give you a 1 in the top and a 3 in the bottom, right? X to the third and X both have what in common? A plain old X, which means this X in the bottom is going to divide away, yeah? But X in the top is X to the third. You divide out one X, you're going to get X what? To the second.
I was right.
There you go. And do I want to leave it like that? Does that look right to you?
No, does the exchange cancel out?
No.
No,
So,
put it to the side. No,
right. So you have two choices. First of all, if you have 1x squared, you don't need that 1 in front. So you could write it as x squared over 3. But in mathematics, especially in algebra, the better option is to simply take the two numbers and take the variable and drop the variable. If the variable is in the numerator, right, just drop it off to the side and get 1/3 x to the second power. All right? So this is the preferred format. This one means exactly the same thing. So either one of them are perfectly fine, but this one will be where you're going. That will be what you want to do. Yes?
So you know how you wrote the answer with like 1x squared?
Mm-hmm.
If we write it like that, would that be wrong?
Absolutely not. It's not incorrect. It's just not the most. It's just not the simplest form you can write it in. Mm-hmm.
When will we even need this in real life?
When you take your math test to get a degree, and so you can move on.
Is that the only time we'll need it?
Yeah.
Then why are we learning it?
Because you need to get your degree.
If you're even doing it, we're only even going to use it for the test that we studied. John.
Okay? All right. So there we go. Now, so that's simplification. Remember, just dividing away common factors, numerator to denominator. Vaguely familiar? Okay? All right. So now let's talk about how to multiply fractions. Now these are algebraic fractions, but I don't even make any I don't care because fractions are fractions. Okay? But you know they're algebraic because they have what in them? Variables. There you go. Some letters. You bet. All right? Now, we're going to use Education Perfect for guys. We're going to use Education Perfect for these activities, but remember that they do this in a way that I do not agree with.
You don't like Education Perfect. It's on the list.
No, remember, they are going to use the old primary school shortcut of multiply straight across and then reduce at the end. But I'm going to tell you that with these fractions, if you try to do that as you move forward in algebra, then you are not going to be able to make it work. So you need to always simplify before you multiply. Because if you don't, it's going to cause you trouble. So your first thing is to simplify. They're going to tell you to multiply across first, but don't. Simplify everything possible first. Because think about it. If you multiply and you end up with 124 and 478, right, wouldn't it be easier to work with 2 and 3?
Yes.
Okay? So if you simplify first, then you're going to be much happier. But remember, when you're multiplying fractions, you have 2 fractions. So I can simplify any numerator to what?
Any denominator.
Any denominator. Do you remember that? Okay? It's exactly the same thing that we talked about before. So it doesn't matter which fraction it's coming from, as long as you're crossing that fraction bar, then you're in good shape. Okay? And then after that, simply multiply numerator times numerator and denominator times denominator. And you might want to look at the final answer just to make sure that it's simplified to its fullest form. But as long as you're careful, it should be in the beginning. Okay? If it's not, then go ahead and just simplify it then. Right? But make sure that it always is simplified to its fullest form. Okay? All right. So what I want to do is, want to go to the Education Perfect lesson on this, and we'll just look at some of their examples. Again, they're going to tell you that they want you to multiply straight across and then simplify. That's bad. It's just bad advice because you need to get in good habits now. Even though the problems are very small. Right now the numbers are going to be very small, so it's going to be easy. But later, it's not going to stay that way. Okay? So here we go. Multiply the following algebraic fraction. We know they're fractions because we see the fraction bar, right? How do I know that they're algebraic?
Because it's like
Have variables or letters in them. Excellent. Also, a thing you need to make sure you remember is watch out for signs because they can have positives and negatives. Here they're all positive, so we're not worried about it. Remember when we're multiplying these, before we multiply, we always what? Simplify. So what we're going to do is look to simplify any factors that are common numerator to what? Denominator. Does it matter which fraction it comes from?
No.
Absolutely not. So watch how I go through this process. The first factor in the numerator is a 2. Oops, sorry. I forgot to turn that on. Is the 2. Okay? And I know it's a factor because it's connected with that x by multiplication, right? And that's what factors are, things that are connected with multiplication. Is there a 2 or anything that has something common to the 2 in the bottom?
Yes.
What?
4.
A 4, right? 2 and 4 will both divide by what number? 2. Okay, so let's go back and divide. 2 divided by itself will turn that 2 into a what? 1. 4 divided by 2 will turn the 4 into a 2. Right? Now, I went ahead and turned the 2 into a 1 and wrote it because I don't know what's going to be left. If there's nothing left, then you need the 1. But if there's anything else there, then you don't. So it's safer just to write it first. What is the next factor in the numerator?
3.
The x to the second, right? There's an x to the second. So that means x to the second means 2 factors of x. Okay? Is there an x or anything with an x in it in the bottom?
Yeah.
Yes.
Yes. It's in the wrong fraction, though.
Why?
Does it matter?
No.
No, absolutely not. I'm just trying to make you trying to make you know that it's okay. So because it's multiplication, it doesn't matter which fraction it comes from. So x to the second and x both have a factor of x in it, right?
Yeah.
So x squared, divide out 1x, you're going to left with what? X. X squared divided by, x divided by itself makes a what?
1.
But do I need to write the 1?
No.
No, because I already have a number there, right? So in other words, it divided away. It really turned into a 1, but I didn't need to write the 1 because I already had a number there. Now we'll go to the last factor, which is the 3. Is there a 3 or anything that divides with 3 in the bottom anywhere?
Yes.
Yes. It's over here in the wrong fraction. Does that matter?
No.
No. 3 and 3 will both divide by 3. So 3 divided by itself makes a 1. 3 divided by itself makes a 1. Yeah? And now I just need to multiply how?
Across.
Straight across. In the top I have x times 1, which is what?
1. Oh, yes.
Yeah, just x. In the bottom I have 1 times 2, which is 2. And x over 2 is a perfectly good answer, but is there an alternative form?
Yes.
1/2
How come
x.
it isn't 1x?
Well, you can write the 1 there, but you just don't need it, right? 1x is the same as just plain old x, isn't it?
With 1 card.
Look at this. This is a pencil, right?
Yeah.
Do I say 1 pencil? No, I don't need to say 1 pencil. If you just say pencil, then you assume there's 1. So, now, if you put the 1 there, that's perfectly fine. It's just not the best format.
Will we
Okay.
get knocked down?
No, not yet.
What?
Next year, yes.
What?
Oh, yeah. Why not?
How about
Putting
if,
a bun.
Yeah.
If
you're in my class, you will. Okay.
Do you have mark spec for anything else?
Come on. This format and this format, I don't care. This one will take you further later. It's going to be the one that you're going to use in the future. But this one is perfectly acceptable. And it's actually perfectly acceptable right now if you leave the 1 in front of the x. I'm okay with that right now. That's not what we're dealing with. The final format of your answer is not the big deal right now. Okay?
What is the
Yes.
deal?
wait, why is the x in front of the half?
I mean, behind it?
What has it behind?
It's on
It's
the
on
right
the
side.
right. It's behind. In front would be
Okay.
the other way.
Because remember, 1x over 2 is the same as 1/2 times x. Dividing by 2 is the same as multiplying by what? 1/2. They're equivalent expressions. So that's why.
Does it mean that like both numbers have x on it?
No, it just means... Right,
Oh, so
hold
both
on.
of them are times in by x.
X divided by 2 is the same as half times x.
Yeah. You're not quite there. You're not quite there. You're trying to, you're making, yeah. Hold on a minute. If you have x divided by 2, x divided by 2 is the same as saying 1/2 times x. If you divide by anything by 2, that's the same as multiplying it by what? 1/2, right? So like if you had, no, don't say that. Hold on. So if I have x over 3, dividing by 3 is the same as multiplying by what? 1/3.
Oh, wait,
Those are
what?
equivalent expressions.
Take the x, put it there, and add a 1 on top.
Well, understand that dividing by any number is the same as multiplying by the fraction with 1 in that number, right? All right, you'll do some more of them and we'll be fine.
That's not saying he-
Now,
What are you doing?
I want to show you what they do with it just so that you can see later when you're doing. So what they do is they break it all down, they multiply all the factors, they move the numbers together, then they multiply all the things together, then they divide it out. Which is a lot more work than we did. It looks very simple. That's because this is the primary school method, and that's what you're used to doing. But that's
Why would the primary school method look harder than the real?
because it is hard. It is harder because you're more sophisticated now.
What is sophisticated?
I'm talking about.
You're more grown up. Okay, here we go. Come on, guys. Let's look at this one. So we're going to multiply this algebraic fraction. First of all, I know it's a fraction because it has a fraction bar, right?
Yes.
Guys, shh. All right. Second, I know it's multiplication because we have a multiplication symbol. How do I know that they're algebraic fractions?
Because of the variables.
Because of the variables. Excellent. But it doesn't really matter because for any fraction rules, guys, any fractions, before I multiply, the first thing I do is, and I simplify it, anything common to any numerator to any what? Denominator. So what is the first factor in the first numerator? 4. The 4. So look at it piece by piece. Is there a 4 or anything that will divide by 4 in the bottom?
Yes.
Yes. So 4 and what?
8.
8. Will both divide by what?
58.
4. Okay? 4 divided by itself will leave a what? 1. 8 divided by 4 will leave what? 2. It's dividing by common factor. What's the next factor in the numerator? An x. Is there an x anywhere in the bottom? Yes. So I have an x to the second in the bottom. So x to the second and x, the most you can ever divide out is the smallest one. So what's smaller, x or x to the second? X. So that means I can divide it by an x. Never divide by more than you have. So x divided by itself makes a what? 1. But do I need to write a 1? No, because I already have 1. In the bottom, x squared divide out an x. What's left? X. Because remember that it's x to the 2 minus 1, which is just plain old x. What's the next factor in the numerator? Y. Is there a y anywhere in the bottom? Yes. In the top, I have a y. In the bottom, I have y to the third. So which one's the smallest one?
Y.
So the most I can divide out is just a plain old y. If I divide y by itself, what's left?
1.
But I've already have a 1 written there, so I don't need to write it. In the bottom, y to the third divided by y is what? Y to the second, right? Because remember, what's happening is you're subtracting those exponents. Oops, sorry, that's not. So it's y to the 1 minus 1, which is the 1, and y to the 3 minus 1, which is y to the second, right? Remember the algorithm? Okay. Now, moving to the next factor. What's the next factor in the next numerator? 6. Is there a 6 or anything that'll divide with 6 in the bottom? There you go. Look, even though, right, it's something that we divided earlier, it'll still divide more.
Wait, so you can divide by
Exactly. As long as, it doesn't matter if it's something that we've divided, right? It's still there. So 6 and 2 will both divide by what?
3.
Well, 2 and you're going to get a 3, right? So 6 divided by 2 is 3. 2 divided by 2 is 1. And I'm not going to write the 1 because I have the y squared, right? You could write the 1 if you want to, but who cares? What's the last factor in the numerator? X. Is there an x anywhere in the bottom? Yep. And they're both identical, aren't they? So this x will divide away to make a 1, which I don't need to write because I already have the 3. This x will divide away to make a 1, but do I need to write the 1? No, because I have that 5 still there, right? If you already have a number, you don't need the 1. Now we've divided everything away that can divide away, so we're just going to multiply how?
Across.
Straight across. In the top, all that's left is 1 times 3, which is 3. In the bottom, we have 5 times what? Y squared, so that gives me 5y squared. Now, would I move that y squared to the side?
No.
Why not? Because it's in the what? It's in the denominator. It's not being divided, it's the thing you're dividing by, right? So if the y squared was in the top, could I move that y squared to the side?
Yeah.
Yes. But since it's in the bottom, it needs to stay in the bottom because we need to indicate that that's what we're dividing by. So it has to stay. So be careful about the two different places where it can occur.
So when it's in the numerator,
You can put it off to the side, but if it's in the denominator, it must stay in the denominator. Okay?
Yes.
Ready to do one on your own?
No.
Sure you are.
Can we do booklet?
So I don't even know what that means.
What is C and D?
Because A and B, I just did the letters and I just put them in alphabetical order. All right. So A over B, will A over B change? No.
No.
Division will become what? Multiplication. And C over D will become what? D over C. There you go.
Reciprocal.
Yes.
Yes.
Wait, how come A and B didn't flip over?
Change to multiply.
Does it matter?
Yes, it does. By the reciprocal.
I've got the power in my brain.
Remember, reciprocal just means to flip it over, right? And you only change the one you're dividing by, never the first one. This first one will never change. It's the one you're dividing by that changes to the reciprocal. Okay? If you change the wrong one, then your answer is going to be wrong. Right?
Okay.
Okay? And then after you change it to multiplication, then you just follow the rules for multiplication, right? So no new rule here except that you can't divide fractions. You change it to multiply by the reciprocal, and then you simply follow the rules for multiplying fractions.
Okay, 1 second.
Okay? Pardon? So we no longer have division with fractions, we have multiplication with fractions. So before we multiply, Claudia, we always first simplify. Good. So tell me, Claudia, what is the first factor in the first numerator? 3. Is there a 3? Guys, come on. Is there a 3 or anything that'll divide with 3 in the bottom?
Yeah.
What? 3 and 6 will both divide by what?
3 and 6. Well, yeah.
3.
There you go. All right. 3 divided by itself is going to leave me with a what? 1. 6 divided by 3 is going to leave me with a what? 2. Excellent. Okay? All right. Okay. Now, let me just show you this really quickly. I know that we're out of time. X to the third and x in the first one, they'll both divide by x, right? But notice there's still more x's in the second one. So that means we can divide again, right? So what does x to the second and x to the 8 have in common? X to the second, right? Which leaves me x to the 6 in the bottom. Is there y common to the bottom? Nope. So that's it. So we'll just multiply straight across. Okay? All right.